To start statistics, we are collecting and organizing different types of data. So you're going to learn how to classify your data into discrete, continuous, qualitative, quantitative. You're going to learn how to organize your data into different types of tables, frequency tables, group frequency tables, and also display your data in different ways, tables, and histograms for today. There are, of course, other different ways that you can display your data, but this is just the beginning part. We'll talk about the other ones in the future. So to start off, okay, these are the different types of data. Okay, you can either have qualitative data or you can have quantitative data. Okay, qualitative data is data that is categorical. Like when you go around and you take a survey of people, like what's your favorite color? What languages do you speak? What's your favorite type of candy? Those are all different examples of data that is qualitative because it's categorical. Okay, does that make sense? Versus quantitative data, which is data that's numerical. So last Friday when you went around and you asked people what was their height, what was their shoe size, that's something that is a number that they gave you. Height, shoe size, time, age, number of types of fish in the ocean, et cetera, et cetera. Okay? Now, with quantitative data, you can have two different types. You can have discrete data or you can have continuous data. Discrete is the type of data that can be counted or take a specific value, such as your number of pets. Continuous data is data that can be measured or takes a range of values, such as height or time. Okay? So the height that you collected in your data, that would be an example of continuous data. Shoe size would be an example of what type of data?
Quantitative.
It is quantitative, but is it discrete or is it continuous?
Continuous. Shoe size, I mean, that'd be continuous, right? Because I mean, it's measuring.
It is, you do measure your foot to get your size, but when you get your size, what size are you? Like, what's your shoe size?
I'm a 9.
You're a 9. What's yours? A 9. What's yours? 7. What's yours? 11.5. What's yours? 9. You're either going to have a whole number or you're going to have a 0.5, correct? All these things, though, that's discrete data. Shoe size is discrete data. Yes, you do measure your foot to get your size, but once you get your size, it is just that. It is 9, 7, 11.5. Okay? Let's take a look at some more examples. Just make sure you guys can understand the difference between continuous and discrete. The number of sweets in a packet.
Discrete.
It's discrete. You can sit there. It doesn't matter how big that bag of candy is. You can sit there and you can count how many sweets are in that packet. The next one should be pretty straightforward. The height of students in grade 8. Continuous. Just like when you went around and got your heights for your data for your project. Dress sizes of a girl's pipe band, like our Scottish student. When they went around, they got their sizes to fit them for their skirts. Is that discrete or is that continuous?
Discrete.
It is discrete, okay? It's a size. Just like your shoe is a size, okay? It takes on one particular number. The number of red cars in the parking lot. Discrete. No matter how big that parking lot is, it could be the parking lot at Raymond James Stadium. I can sit there and I can count the number of red cars that are in that parking lot. Okay? So think of it like this, okay? Could you actually go out, could you count like whatever it is that is asking you to determine if it's continuous or discrete, or is it something that, or can you not? Such as the weight of kittens. Can I count that? So this would be an example of continuous. What about the marks obtained by grade 7 on a science test? Discrete. Just like the marks you obtained on your functions test, which you'll get back in the period, that data was all discrete data. Times taken for students to write their world literature paper? Continuous, okay? Time always takes on a range. Even though if it takes you 30 minutes to write a test or to write a paper or whatever, that still is time. Time is always measured. And the number of heads when a coin is tossed 60 times.
Discrete.
That is discrete. Questions?
So most time when it says the number of, it's going to be discrete.
Always, yes.
basically like continuous data is something that you can't really like eyeball on. Like something like height, you can't really eyeball on that. You need like a scale or something like that, or like with weight, you need a scale.
Correct.
Okay.
And just like with shoe size, like you either are 9 or you're 9.5. There's no 9 3/4 shoe. There's no, you see what I'm saying? Okay.
So there's kind of like a little bit of wiggle room when it comes to continuous, but not with discrete.
Correct. With your data, you can either have random data or you can have biased data. Random is data that's fair. There's no bias. Everyone has an equal opportunity of being chosen. Biased data is data that's unfair. It's grouped unequally or with an advantage. So my question to you, when I told you to go out and get 60 pieces of data on Friday, was that random data or was that biased data?
Random.
Why do you say random?
Because we were not looking for specific people, we were just looking for people in general.
Very good.
If we were looking for like a range of different like classes, like freshmen, sophomores, juniors, seniors, would it be like biased with us going to the specifically 9th grade classes?
Yes, now that would be an example, right? Let's say that only the IB teachers have responded to my email saying, yes, you could come in. That would be biased data because you're only going to IB teacher classrooms. But because I had other teachers like Joseph and Oguntola that you guys could have gone to, that made it random, okay? Still has a little bit of bias because it was only a certain people that did respond, but that was more random than if I just said, okay, you're going to just these IB classrooms, okay? So, knowing that, I want you guys to answer these next 4. Is it random data or is it biased data? So I'm going to give you guys a few moments to answer that. For number 9, when researching if people eat breakfast, only interviewing people in the canteen. First off, what is a canteen? It's a cafeteria, okay? It's with folks in like the army and stuff. That's what they kind of call their mess hall or whatever. Random or biased?
Bias.
Very much so, okay? There could be people eating other places, probably not on like a military base, but like here in the cafeteria, like in our school, they eat in the cafeteria, they can eat outside, they can eat in the teacher's room. That's very much biased. When researching spending habits, interview every 3rd person you meet. Random. There's no rhyme or reason, okay? You can stand right outside the mall and every 3rd person that comes out, you can ask them whatever your question is. You can collect your data that way. When researching spending habits on cars, Josh interviews men exiting the garage. Biased. Why is it biased? There's women too. When researching the sleeping habits of children, Adam distributes questionnaires to the students in his school. Biased. Very much so. Okay? Just like here. Let's say you're doing a project, right? And you're collecting data of high school students or something like that. If you just stick to Lake Wales High School, that's very much biased data because there's other high schools in Polk County, right? Okay? So, there you go. Questions on the type of data that you have. How to classify data. So there's 2 types of data. What kind of data could you be presented with? Qualitative, quantitative. Qualitative is what type of data?
That could be categorized like color, range, gender.
Categorized versus
Quantitative, which is like numerical.
quantitative, which is like numerical. Remember, within quantitative, you have not random and biased. You have discrete and continuous. Okay, think discrete can be counted. Continuous, it can be measured. Okay, and then you have random and biased data as well. Okay. Now, whatever data that you end up getting, preferably quantitative data, you can classify it into what's known as frequency tables, or you can place it into a frequency table. All right? When there's a large amount of data, it's easy to organize this data into a frequency table. And by large amount of data, I mean data that's probably more than 20 pieces of data. Okay? So the data that you guys collected on Friday, those 60 pieces, that was a lot of information. Because we're going to be doing a lot of different things throughout the statistics unit with that data, at some point in time, probably today, depending on how far we get, but definitely by the end of this week, I'm going to ask that you put your data that you collected into a frequency table. Okay? Now, a frequency table basically tells you the number of times an event occurs, or a category occurs, or a group occurs. Okay? So a frequency table is basically the condensed version of all of the data that you collected. For example, we have the number of sweets in 24 packs are shown. Okay, we're going to make a frequency table with this data. So all of this here represents your raw data of the 24 packs and how many sweets that were in there. Okay, as you can see, there's some repeated numbers. Those numbers are placed into one column of your frequency table. Okay, you have 20, you have 21 a few times, you have 22 sometimes, etc., etc. Okay? The tally marks is just one way to help you as you're going through your data to organize and to figure out how many you have. Okay? So when you look at your data, how many times does 20 show up? 2. You have one right here, and then you have one right here. That's a total of 2. Okay? Actually, someone do something with this later. All right, when you take a look, how many times does 21 show up? 1, 2, and 3. So that's 1, 2, 3. What about 22? We have 1, 2, 3, 4, 5, 6, 7, 11, 12. Sorry, not 8, 9, 10, 11, 12. Go through the rest and figure out how many 23s and how many 24s you have.
22 is a 21 in the bottom right on our thing.
There's an extra 21?
It's like there's a.
Huh?
There's 22 and 21 here, but there's 20.
Oh, it's the staple that you did. There's actually a whole other line.
There's another line.
There's a whole other line.
Oh, I didn't. Okay.
So there was 12 for 22, correct? How many for 23? And how many for 24? 2. Okay? Now you'll know if you did this correctly and accurately is right here. Because you were told that there were 24 packs of candy that were used for this collection of data, your frequency should add up to be that number. Okay? 2 plus 3 is plus 12, plus 5, and plus 2, 24. Okay? You'll know if you did it correctly if the number does add up. Now this column right here, this tally mark column, that is not necessary to create your frequency table. Okay? However, if you have like 200 pieces of data, it might be easier to do the tallies and then to double check before you go through and just try to do the count. Okay? But a frequency table only has that left column and then that right column. Great question. So the question was for like the data that you collected, would you have one for heights and one for shoe size, or could you do them all together as one? You would have to do 2 separate ones, one for your height and then one for your shoe size. Now in that case, also, when we're going to talk about it a little bit later today, you wouldn't do this type of frequency table, okay? Because if you notice your heights, there was a range of different heights, right? You had from like 60, you had like 5'5", which is 65 centimeters or inches, and then you had maybe you had somebody that was 6'1", okay? You wouldn't do one individual row for every single height, because you could have somebody that was 4'11" all the way up to 6'2". That's a very large frequency table, okay? For your shoe size, that might be a little bit smaller, but depends on what your largest foot was that you got. Right? Let's take a look here. I want you guys to do this one on your own. Says the number of games played in matches at a badminton tournament are recorded below. So this here is your raw data. There is the frequency table that represents the number of games that were played and their respective frequencies. I want you to find the value of M and N. What was the value of M? Okay, I hear some discrepancies. Is it 5 or is it 6?
6.
It is 6. That's 1, 2, 3, 4, 5, and 6. And what about the value of N? 3. That is 1, 2, 3. Another way I could have checked this is that since this was 6 and that this was 3, and I had 12. At 22 pieces of raw data, I could also have added up these numbers to see if they equal 22. Question. This is how you go through and you create frequency tables, okay? Here I'm going to let you guys create your own classes, your own frequency table here for this data. Okay, so in this particular one, Shelby surveyed the number of households to find out how many pets they owned. Okay, now real quick, was this data discrete or was it continuous?
Discrete.
Very good. Okay, I'm going to try to circle back through some of the things we talked about in this period as we go through when we deal with a few other things, okay? So what did you guys put for your class? 0 through 1? Through 4? Individually? Okay, so I just want to be sure because what we're going to talk about next is grouped frequency tables. So when you said 0 through 4, that actually represents like a distribution for a group frequency table. Mm-hmm. So 0, 1, 2, 3, and 4. I'm not going to worry about the tally column because that's what you guys potentially use to go through and do your count, right? Okay, but what was my frequency for 0?
4.
And 1?
6.
And 2?
5.
And 3?
3.
And 4?
2.
2. Okay, well, based off of this raw data, 1, 2, 3, 4, 5. 5 times 4 is 20. My total here should add up to be 20. 4 plus 6 is 10. This becomes 5. 5 plus 5 is 10. That is a total of 20. So very good. How do you feel about creating a frequency table? Pretty good? Okay.
Just remember the other ones.
Hmm?
So there are more than one frequency table.
There's more than one type of frequency table, yes. Okay? All right. So then what we're going to do is going to have you guys get up and move around for a little bit. What I want you guys to do is I want you to go around and I want you to record, not the ages of people in this class, because I'm pretty certain everybody here is how old?
16 or 17.
16 or 17. That's not going to give us that big of a table. So instead, let's
But like in like 1/12 or 2/12, depending on like.
what's something that we can count? What's the type of data that we could count? Yes. Wonderful. I want you to go around and I want you to get the number of siblings for everybody in this classroom, and what I want you to do is I want you to create a frequency table with that information. So you're going around and you're recording the number of siblings that everyone has. So there's 2, 4, 6, 8, 10. There's 12 of you guys in here, so it won't take that long.
Could we all just say like?
No, I want you to get up and move around. Mm-hmm. How did you label your table? What was at the top? Okay, well, you definitely want to make sure that you so we're gonna label this siblings will be the best thing, or number of siblings, because that's what we asked for, right? What was the second column? Very good. And what were our numbers?
0, 1, 2, 3, 4, 5, 6.
Oh, look at that. So
Mm-hmm. How many zeros? How many people are only child?
3, 2. Oh,
2. How many have one other sibling?
3,
How many had 2 siblings?
4.
4,
How many had 1?
1,
And how many have 4?
1,
How many have 5?
1,
How many have 6?
1.
Does it add up to be the 13 people in the class?
Yep.
Very good. See? Nice and simple.
For now.
For now. All right. But if you notice, that is for definitely discrete data and data that can kind of be individualized. 0 siblings, 1 sibling, 20 numbers of sweets in a packet, okay? But for ones that aren't as simple, you have to create a frequency distribution, okay? It is still a table, okay? It's very much still a table, but the difference between this and the other one is that a frequency table shows classes, intervals, or groups of data with a count of a number of entries. Okay, so it shows classes, intervals, or groups of data with the count of the number of entries. Okay? So when you look at this example here where it says identify the class, lower class limit, so on and so forth, this here, it looked like they had some responses that could have been anywhere from 1 all the way up to 30. You're not going to create a frequency table with basically 31 rows to indicate 1 through 30. Okay? But what you can do is you can create a frequency distribution which basically groups a certain number together in a particular class or group. Okay? So let's go over some vocab here real quick about what everything is, so then that way you'll know what all these different things stand for. So vocab-wise, classes, okay? Classes, you can basically describe that as an even grouping of your raw data. And by even grouping, that basically means that however you distribute your classes, they basically have the same class width. Class width basically represents the size of each group. And the thing is that when you yourself create these frequency distributions, you want your class width to be the same for every interval. The lower class limit is basically the smallest value in that respective class. Okay, so it's the smallest value in each class. So if you look at the very first class, what is the lower class limit?
1.
It is 1. Very good. And then, of course, the upper class limit would be
Largest value.
it would be that largest value for each class. So if I look at this particular class, what would be the upper class limit? Where the arrow is.
25.
It'll be 25. There we go. Now the range of your data is basically when you take the largest value and you subtract it from the smallest value overall. So for all of your data. Okay? And usually this distribution either comes from like your raw data, so you can always kind of see, okay, what's my largest value, what's my smallest. Okay? So there is some vocabulary for you. So your classes, if it asks you to, which it does, it will never ask you to do this, but when you create your own, you will have to do this. Identify your classes. It would be each and every individual class written down. Okay, so 1 through 5, 6 through 10, 11 through 15, 16 through 20, so on and so forth. That's how you identify the classes. Then you identify the lower class limit for each class. What is the lower class limit of each class? Of the first class, what's the lower class limit?
1.
Next one.
6,
Keep going.
11, 16, 21, 26.
Okay, if it asks you to identify the upper class limit of each class, it would be
5, 10, 15, 20, 25, 30.
if it asks you to identify the class width, you basically look at each class and see, okay, exactly how wide it is. What is the class width?
5.
It is 5. That includes 1, 2, 3, 4, 5. If you look at, say, this fourth class, 16, 17, 18, 19, 20, every single one has a class width of 5. And then the range, you take that from the largest value minus the smallest value overall for your data. So what's your largest value? 30. What's your smallest? So you subtract that to get 29. Okay? Now, realistically, IB will probably ask you what is the lower class limit for the fourth class? Or what's the upper class limit for the second class? They'll ask you specifically for a class. And all you do is you just count to that respective line and you provide that information. Questions? Now, these frequency distributions is more of what you would create for the data that you collected on Friday. Okay? So a few guidelines when you yourself have to construct a frequency distribution. The first thing you want to do is you want to first determine the amount of classes you would like to include in your frequency distribution. Okay? Somewhere between 5 classes and 15 classes works best. Okay, of course, the more classes you have, the more you're going to have to do with each class to do different things, like creating histograms, cumulative frequency curves, finding mean and median, which we'll talk about in the future. Okay? After you figure out how many classes you're going to create, then you want to find the class width. Now remember, the class width is equal amongst all of your classes. What you want to do to determine what the class width is you want to divide the range of the data by the number of classes you chose in step 1 and then round up. Because a lot of times it won't go in evenly, so then you just round up and then that's the size of your, or that's the class width. Okay? After that, you want to find your class limits. Okay, you want to find your upper limits and you want to find your lower limits. To do that, you use the minimum data entry. For the lower limit of the first class. And then from there, you want to add the class width to the lower limit to find the lower limit of the next classes and repeat. For all of your classes. After that, then you need to write your upper limits. So let's go back over step 3. Once you determine your classes and you figure out your class width, you use the minimum data entry from your raw data, and that becomes the lower limit of your first class. Whatever that lower limit is, you add the class width to those values and continue to repeat till you get basically to your maximum data entry. Okay? And then, of course, you repeat that for your upper limits. Now you have basically that first column in your frequency distribution. So you use tally marks for each data entry to determine how many data points fall in each class. And then, of course, you want to count up your tallies to find the frequency for each class. So these are your guidelines for constructing a frequency table. You are going to have to construct one for the data that you collected on Friday. But before we get to that point, we are going to practice in creating it for these next few examples, okay? Any questions on our steps? All right. So when you flip over your page, you have the steps kind of shorthanded off to the side, but we're going to do it for this particular one here. Okay? So we're going to construct a frequency distribution that has 3 classes for the age of inauguration for the first 30 presidents of the United States. This one tells us exactly how many classes we have, but the next example does not tell us how many classes we are going to have. So we're going to have to create that one 100% on our own. Okay? So how many number of classes are we going to have?
3.
We're going to have 3. Again, the problem told us that we're going to have 3 classes. Now you yourself, if you notice, this is what 30 presidents, you have 60 pieces of data, you should not have 3 classes. You should have a minimum of 5, but definitely no more than 15 when you do your own data. Okay, so we have 3 classes. Sorry, I meant to put that there, not up there. What is my minimum data entry?
49. 42. Oh.
The smallest data point in this data is 42. Now, somebody see something different? What's the maximum data entry?
68.
68.
We got a 68. Okay? So remember, to find the class width, we need to figure out what our range is, and then we need to divide it by the number of classes. Okay? So to find the range, we do what?
68 minus 42.
So we need to do 68 minus 42. What's that number?
26.
26?
Yes.
26, and then we're going to divide it by our number of classes, which is 3. What's 26 divided by 3? 8.666, and so we need to take that number and round up. So what's my class width going to be? 9. Questions up to this point? This is what you yourself are going to have to do with your data to create your frequency distribution, okay? But you're going to determine how many classes you want to work with, okay? And to be honest, if you want it to be maybe your class width to be a whole number when it's divided, find out the range first and then determine your classes from there.
Now, with the class, like, do we use the shoe size or do we use like your height?
You're going to create 2 of them. So you're going to need to do one for your heights and your shoe sizes. Okay? So now we need to basically find our class limits. Remember, from step 3, we need to use the minimum data entry for the lower limit of the first class. So what was the minimum data entry?
42.
42.
And just add 9 to that.
So 42, and we're going to add the class width to that number. So what's 42 plus 9? 51. What's 51 plus 9? 60. Okay, very good. And so then what we're going to do is we need to create our upper limit. Okay? And since our widths have got to be the same size, or our classes have got to be the same width, the same size, we're going to add 9 to 40, or it needs to be a width of 9. So that's 42, 43, 44, 45, 46, 47, 48, 49, and 50. So our upper limit is going to be 50 for our first class. That creates a width of 9. And then we continue to add 9 to the upper limit. So what's the upper limit of the second class?
59.
And the upper limit of the third class?
69.
Now, do you need to write it with the like less than or equal to sign with X, or could you just do the dashes like in the
What you're going to see on IB questions when they give it to you, you're going to see it written as the inequality. And real quick, what is 59 plus 9? 68.
Oh, that is 60.
Now, the upper bound does make a difference, or it does matter, especially when you get to displaying this information in like a histogram or other items that you're going to learn about later. The one thing is you want to make sure that there is no data hanging in the wind, okay? Because this relates to the ages of the first 30 presidents, there is no 50 years and 6 months old. You see what I'm saying? Like they're 50 years old or they're 51. So there's nothing in between. However, for data such as shoe size, then you have some people that said they were like 9.5, like 9.5, something like that. You are going to have to take that into consideration when you create your frequency tables. Your frequency distribution. So now that we've done the hardest part, which is creating the classes, now we can complete the rest of the frequency table. Okay? So go ahead and go through this raw data and figure out where does each piece of data fall, which class. Okay?
How did you guys go from 42?
Because remember our class width was 9. So it included 42, and then from 42 we went 9 up to get to 50. But you got to include 49 or 42, so 42 is your first. Got it. So real quick, if you're confused on what we're doing, 57 lies in which class? The first, the second, or the third? Second. 61 is in which class? Third. And you're going to continue this to figure out what's the frequency of each class. So going through the process of figuring out how many go into which class, what was your frequency for the first class?
8.
8. It should have been 8. And if we look in orange, I'm going to circle it between 42 and 50 inclusively. That's 1, 2, 3. Ooh, nope, a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9.
You circled 51.
Where?
At top.
Ah! I'm under the pressure. I must be nervous. All right, there we go. You have 8. Okay. What about in the third class?
17.
The third class.
Oh,
5.
5. Now, there's a reason why I asked for the third class because I knew the second class was the largest one. So I just kind of want to go through and do 60 through 68. So I'm going to make sure I do this right. 1, 2, 3, 4. And the next. So that's a total of 12. So that means I should have 13. That means I should have a remainder of 17, which is what is left for a total of 30. Questions?
So if you can eyeball the smallest and the largest, it's easier just to add those two together and subtract it from the total.
That's usually what I do. Questions? Now again, this is an example of frequency distribution. As you can see, the upper limit of one class is different from the lower limit of the second class. That works here because we are talking about ages. However, sometimes you are going to need the upper bound of one class to overlap with the lower bound of the next class. That just means that you adjust the inequality for each class. Lori made 30 phone calls, in 1 week. The times in minutes are recorded. As you can see, we have a 0.2, a 0.8, a 0.5, etc., etc. So we're not going to be able to go to 2 minutes and then 3 minutes because there is a 2.9-minute conversation. Okay? So in those cases, when we create our frequency distribution, the upper limit and the lower limit are going to overlap. But first, let's determine how many classes are we going to have. When you do it yourself, what's the minimum number of classes you can have?
5.
5. Okay, you guys want to do 5 classes? You want to do 6, 7, 8, 9, 10? How many?
5.
You want to do 5? Okay. Now, if you decide to do 5, the next thing you have to do is you have to look at your range to determine your class width. Okay? Depending on what our range is, we might can change that number of classes. Okay? What's my maximum data point?
35.4.
35.4. We're going to subtract that from my minimum, which is what?
1.2.
1.2. So when I subtract that, what do you get?
34.2.
Okay? So if we keep it at 5, what's 35.2 divided by 5?
6.84.
6.84. So then from 6.84, we round up. So our class width is going to be 7. Okay? So our class width is going to be 7.
On the test, is that the same total? Is that what the sign is going to be?
That let's talk about that that real quick. Yes. This symbol right here, that does mean sigma, that means sum. So that's the sum of all your frequencies. Going back real quick for that. Okay. Now we need to create our
Table.
frequency distribution.
Not including tallies, right?
We do not have to include the tallies if you do not want to. And that's just there as a guide to help you if you need it. Okay. So I'm going to have 5 classes. I think that's what we decided on. So that means I need 6 rows, 1 for the title, and then of course the other 5 for the actual classes themselves. What am I going to title the left column?
Oh, I mean.
The time, okay, time recorded, time of calls. This is in minutes. And then the second column is going to be frequency. Okay. Now we need to create our lower limits and our upper limits. Now we can either do this by using the lowest value, the minimum value, or since our minimum value is 1.2, we could use 1 also. To be honest, it's up to you whether or not you want to deal with the decimals as your classes or whole numbers as your classes. Which one do you want to do? Whole numbers. So since 1.2 is your lowest, your minimum entry point, then you want to go down to the next whole number, which is 1. Okay? So 1 is less than x. And
It should be to like 6, right?
Because you have to add the minimum, the lower limits by 7.
yeah, you have to add the lower limits by 7. So this would be 8. But this is also what I was talking about here. If I add 7 up here, this gives me an upper bound of 7. Is there a 7 point anything in my data?
Yes,
So we can't not include that. So we are either going to make this an 8 or we're going to make this a 7 and make sure that the lower limit of the second class is going to be a 7 as well, so we do not miss out on that data point. Does that make sense? Okay? If I make this a 7 and I say that this is my first class, where am I going to put the tally mark for that entry point? Because it won't belong in the first class, nor will it belong in the second class. So either I'm going to make both of these 7 to take care of the fact that it's going to belong in one of those classes, or I'm going to make them both 8, so then that way that particular point can fall in the class.
Would you count it twice? Like if you
I would not count it twice, so it would not be included in this one, but it would be included. I did.
Yeah, because the first one's only going up to 7.
But this one would include any data points that are equal to 7. So then this is how all of your inequalities will be set up.
Interesting.
Questions? So again, I asked them, I'm going to keep this at 7, I'm going to make it 8.
7.
Keep it at 7? Okay.
More than 5 classes.
So I'm going to need more than 5 classes if I make it 7. If I make it 8, will I need more than 5?
No. So let's make it 8.
Okay, so then I'm going to need to make it an 8. Good observation. I saw a hand up in the back. Okay, so then I'm going to make this 8. Keep adding 7, so then that'll be what next? What will be the next number? 15, so that'll be 15 here, 15 here. Keep adding 7. 22 here and 22 here. 7 one more time.
29. Oh, wait, yeah, you would have enough.
I have enough? Okay, what's 29 plus 7?
36.
Does that include my maximum?
Yes.
Okay. And every point is accounted for because I'm going to go all the way up until 8, but not equal 8 in the first class. But any times that are actually equal to 8, that will be in the second class. So let's do it one more time. Let's plug in our frequencies. Let's figure out our frequencies for Lori's 30 phone calls. So one thing we definitely need to make sure that we fix for this problem is the fact that there's not 30 telephone calls. When we copy this over to make this foldable, we missed an entire column of data. So that's actually 25. And did you guys get these values? Okay. The one thing you want to be careful of is this one right here, this 15. Okay, remember 15 is not included in the second class, but it is included in the third class, hence the compound inequality. Anytime an upper limit overlaps with a lower limit of neighboring classes, it's not going to be equal in both of them. It's only going to be equal in the second. Okay? Questions on creating your frequency distribution tables. These steps here are going to be what you need to do and what you need to follow. Any questions?